Unit 1, Stormwater 101, Lesson 3, Traditional Stormwater Management. In the last two lessons, we covered the disruption of the water balance and some of the impacts of urban runoff pollution. Before we can get to some of the solutions, we need to have a better understanding of the way current stormwater management systems are working and how they contribute to some of the problems around urban runoff. We've asked a few experts to help out with this lesson.
Oh, sure.
Yeah.
I'm Manif Ahmed. I'm a water resources engineer at the City of Mississauga.
I'm Kristen Tully. I'm the vice president and co-founder of Swim Drink Fish, and one of our programs is Lake Ontario Waterkeeper.
My name is Bill Trenuth, and I am a program manager within the Integrated Water Management Division at Credit Valley Conservation.
We're generating more volume and more flows of runoff from the surface, and much less is actually going back into the ground. So how we handle that in an urban situation, even in a rural situation, is we're trying to essentially get runoff back to a receiver of some sort, a creek or a water course. Ultimately, it could be a lake. How we do that is in rural drainage systems, which is streets that do not have storm sewers. They might have ditches and shoulders on the roads. Is those ditches will convey the storm water when it comes off of the road and then off of properties, and then it will take it eventually through culverts and ultimately maybe into a creek or a water course that takes it out into the lake. Urban systems are those systems that involve curbs, gutters, and storm sewers. So essentially what we call gray infrastructure. Gray infrastructure are things like pipes and head walls underground that stormwater would actually go into. It does end up in the same places, except it can get there a lot quicker. In very heavy storms, those that are less frequent, the storm sewers, there's not enough capacity in them. They weren't designed to have those storms that aren't as frequent. In those cases, what ends up happening is those are called major storms. It would take, for example, roads and walkways to get to those same routes. So essentially what we're finding is a safe route for major flows to travel rather than going into people's basements, people's backyards, basically onto private property. So we're trying to keep it into safe public property all along its journey until it gets to a safe outlet.
In our cities, there's pipes that run underneath the buildings and underneath the ground. They capture rainwater that falls if there's nowhere else for it to go, and they also capture the wastewater, so from homes and businesses, so what you flush down your toilet, what goes out of your washing machine when you're doing laundry, what goes out of your dishwasher, as well as businesses, dentist office, restaurants, things like that. All of that water has to go somewhere. And in older cities in North America and other parts of the developed world, it was quite common that these pipes, the ones that capture rain and ones that capture sewage, are actually connected to each other under the ground. That's what a combined sewer is. It means combined stormwater and wastewater.
And so the challenge with that is the amount of volume then that's going into the wastewater treatment plants. You see, with separated sewers, sanitary sewers and storm sewers, the storm sewers would go, whether treated or untreated by stormwater management measures, they would go out to the receivers, creeks, lakes, rivers, water courses, etc. Sanitary sewers, they would actually go to wastewater treatment plants. The wastewater treatment plants would treat the effluent, which would then go out to more than likely the source of intake for water treatment plants, for example.
Whenever there's too much water in a system, it overflows into the closest water body, so the lake, the river, the creek, the ocean. The systems were designed to overflow into water bodies, and maybe without a full understanding of what the environmental impacts would be of putting raw sewage into the environment.
Inflow and infiltration then is an additional input into a sanitary sewer that can come from, for example, infiltration of groundwater into the sanitary system through leaks in the manholes. There's weeping tile drainage. And there is, for example, downspouts, either accidentally or by convention. Weeping tiles and downspouts have been connected into the sanitary sewer. And this could be because sanitary sewers were the only sewers that existed at the time of construction, before perhaps storm sewers were constructed when roads were urbanized, or because it was essentially more easily accessible for the builders at the time, unfortunately.
some wastewater treatment plants, when they have too much water coming at them, they will bypass partially treated sewage, so sewage that doesn't get full treatment so that they can get it through the system faster. That can still have an environmental impact. And then there are wastewater treatment plants that bypass completely.
I'll just add that the other major problem with inflow and infiltration is sewage backing up into basements, and this happens even in areas without combined sewers.
Traditional approaches to stormwater management, there was a strong over-reliance on end-of-pipe control. So what that means is that rather than managing stormwater where it falls and treating it at its source, in yards, driveways, etc., all of that water was really efficiently collected and conveyed through storm sewer pipes and brought to places like stormwater ponds, which were sort of at the end of the pipe of these development communities or these urban areas. And most of the management in terms of quantity, peak flow, and water quality was all kind of done at that end of pipe facility.
Over time, the types of things that we've paid attention to in terms of stormwater has increased. So flooding was obviously always a major concern. So flooding, water quality, and then we start to progress to other elements such as water balance, runoff volume reduction, infiltration, water temperature. Essentially now, 2018, we have a full scope of concerns to address in terms of dealing with stormwater runoff.
So I hope this lesson has given you a better understanding of the kinds of stormwater management systems we have in most of our communities. Even though the technology is improving, we're still dealing with the legacy of decades of outdated and aging systems. In the next lesson, we'll talk about green infrastructure and how it can reverse some of the damaging trends of urbanization, as well as having many other co-benefits.